Ladies and gentlemen, welcome to this episode of my tutorial video channel. In this episode, I would discuss the relationship between and or shapes of short run average cost curve and short run marginal cost curve. This is part 1 of relationship between oblique shapes of average cost curve and marginal cost curves. This is part 1, and in part 1 I will discuss only short run average cost curve and short run marginal cost curve. Now the postulation is that the short run marginal cost curve hits the short run average cost curve at the latter's minimum point. So if we draw the diagram, then short run MC curve hits short run AC curve at the latter's minimum point. This means the short run marginal cost is intersecting the short run average cost at the latter's minimum point. So we measure quantity on x-axis and cost along the y-axis. So we get short run average cost curve like this, and this is short run marginal cost curve. This is the minimum point of short run average cost curve. Let this point be M. So this is the postulation that short run marginal cost curve intersect the short run average cost curve at the latter's minimum point. This means the marginal cost is equal to the average cost when the average cost is minimum. Now this postulation leads us to two hypotheses. Number one, when the average cost falls, marginal cost lies below the average cost curve. So this is the first hypothesis, and this says when the average cost is falling, then the marginal cost curve must lie below the average cost curve. And why this happens? This happens as the rate of fall of marginal cost is more than the rate of fall of average cost. The rate of fall of marginal cost is more than the rate of fall of average cost. That's why when average cost falls, the marginal cost curve lies below the average cost curve. And what is the second hypothesis? Second one is when the AC rises, when the average cost rises, the MC curve lies above the AC curve, because the rate of rise of MC is more than the rate of rise of AC. So when AC is falling, look at this diagram. When AC is falling up till point M, M is the minimum point of short and average cost curve, that is SAC, and up till this point SAC is falling, and you see the marginal cost lies below the average cost curve. On the other hand, beyond point M, the average cost is increasing or rising, and when this average cost is rising, marginal cost curve lies above the average cost curve. And why this happens? This happens because of the rate of change of marginal cost is more than the rate of change of average cost, whether it increases or decreases. The rate of change of marginal cost is always more than the rate of change of average cost. Now we shall take one numerical example to see whether these two hypotheses are correct or not. Sorry. If these two hypotheses are to become true, then the marginal cost curve must intersect the average cost curve at the letter's minimum point. There is no other point on the average cost curve where marginal cost curve can intersect other than the lowest point of SAC, if these two hypotheses are to be true. So now we shall take one numerical example to see whether this follow or not, and after that I shall explain diagrammatically that the marginal cost curve indeed intersects the average cost curve at and only at the minimum point of the average cost curve, and finally I will use calculus to show that. So for timing, let me erase this part. Maybe I need to write it sometime later, but right now I am erasing this part, okay? Because I have to proceed further. Yeah. Now we shall take one numerical example, that is to say a set of cost data, that is total cost, marginal cost and average cost for production different units of output. This is units, this is total cost, this is marginal cost, and this is average cost. Let me complete the unit first, then I will explain everything to you. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. These are the different levels of output, 10 units to 20 units. Let the total cost of producing 10 units be 90. Yeah. For 10 units, total cost is 90. For 11 units, total cost is 98. So marginal cost of producing the 11th unit is 8. The total cost for producing 12 units is 7. The total cost of producing 13 units is, total cost of producing 12 units is 105. So marginal cost of producing 12 units is 7. And this way, this goes on. And you can see that marginal cost is falling from 8 to 7 to 6 to 5. And then it again increases. Again to 6 to 7 to 8 to 9 to 10 and 11. Now let us see the average costs. This is 90 by 10 equals to 9. This is 98 divided by 11. This is 105 divided by 12. This is 111 divided by 13. This is 116 divided by 14. This is 122 divided by 15. This is 129 divided by 16. This is 137 divided by 17. This is 146 divided by 18. This is 156 divided by 19. And finally 167 divided by 20. These are the different average costs for producing different number of units. So 98 divided by 11. Let's see what we get. Eight point 8.909, let us take 8.91. Then 105 divided by 12. And we get 8.75. Then 111 over 13. So we get 8.538, let us take 8.54. Then 116 over 14. So we get 8.2857, let us take 8.29. Then 122 divided by 15. This gives us 8.13. Then 129 divided by 16. 129 divided by 16, we get 8.05. We take 8. We can ignore 0.05. When we are talking about the marginal cost is intersecting the average cost curve at let us minimum point, this means when the average cost is minimum, it becomes equal to marginal cost. There may be very small difference. I mean to say, they can be very close to each other and we can consider as those are same. Now 137 divided by 17. 137 divided by 17. We get 129 divided by 16 gives us 8.06. And here 137 by 17 we get 8.05. 05 we can take it as 8.0 as I was talking just now. That is, for producing 17 17 units, the average cost and marginal cost become equal. Now let us see what is happening when the farm produces 18 units, 19 units and finally 20 units. So 146 divided by 18. So you get 8.11. Then 156 divided by 19. We get 8.21. And finally 167 divided by 20. So we get 8.35. Okay. Now you can see therefore for 17 units of output, marginal cost is equal to average cost, and when the average cost is minimum, because average cost is falling from 9 to 8.91 to 8.75 to 8.54 to 8.29 to 8.13 to 8.06 till 8.05, which we have taken as 8.0. And after that, that is from 18 units, the average cost is increasing 8.11 to 8.21 to 8.35. On the other hand, marginal cost is falling from 8 to 7 to 6 to 5. That is still 14 units. After that, marginal cost is increasing. Now you can see when the average cost is rising, till here average cost is increasing, AC is increasing. Sorry, I mean to say AC is falling. From here to here, average cost is falling. Average cost is going down. And you can see the marginal cost is less than average cost for any level of output. For 11 units, average cost is 8.91, marginal cost is 8. For 12 units, average cost is 8.54, marginal cost is 6. For 14 units, this is average cost is 8.29, marginal cost is 5. For 15 units, AC is 8.13, MC is 6. For 16 units, AC is 8.06, MC is 7. So, for every average cost, the amount of marginal cost is lower. That means when the average cost is falling, the marginal cost curve lies below the average cost curve. So, these are here average cost is falling and the marginal cost curve lies below the average cost curve. So, the first hypothesis is proved to be true. Now, what about the second hypothesis? From 8.05 to 8.35, average cost increases. And when average cost increases, you see, for every average cost, marginal cost is more. When AC is 8.11, MC is 9. When AC is 8.21, MC is 10. When AC is 8.35, MC is 11. So for every average cost, from 17 units onward, the marginal cost is more than the average cost, the corresponding average cost. This means when the average cost is increasing, marginal cost curve lies above the average cost curve, and here you see this thing is happening beyond point M, that is the minimum point of SSC. SSC is rising, and as SSC is rising, the marginal cost curve lies above the average cost curve. So both the hypotheses are proved. That means the short run marginal cost curve would intersect the short run average cost curve at the latter's minimum point and at no other point on the average cost curve. Now I shall explain once again this with the help of calculus, and for that I have to erase this part. Okay. Yeah. So I take liberty to erase this part. Since I have to proceed further, I have to show how you can prove those hypotheses by using calculus. Okay. So let us take a cost function. Here I am using calculus. Let the cost function be c equals to q cube minus 6q square plus 15q. You can take any other cost function, but you will get the same result at which you must focus. What is the result? You can take any cost function. I have taken this cost function so that I can get round figures. Correct? Now c equals to q cube minus 6q square plus 15q is the cost function. That is total cost equals to q to the power 3 minus 6q square plus 15q. Now marginal cost MC is equal to ddq of c. If we differentiate the total cost, we get marginal cost. That is marginal cost equals to ddq c equals to ddq q to the power 3 minus 6q square plus 15q. Okay, equals to 3q square minus 12q plus 15. When you differentiate q cube, we get 3q square. As you differentiate 6q square, we get 12q. And as we differentiate 15q, we get 15. So marginal cost is 3q square plus 12q plus 3q square minus 12q plus 15. This is the marginal cost according to the given cost function c equals to q to the power 3 minus 6q square plus 15q. Now let us see what is happening in case of average cost. Now average cost AC equals to C by Q, which is equal to Q cube minus 6Q square plus 15Q divided by Q, which is equal to Q square minus 6Q plus 15. So this is the average cost. The cost function is q cube minus 6q square plus 15q, and we have divided the total cost by quantity q. So we get q square minus 6q plus 15. This is the average cost. Now, when the average cost is minimum, the derivative of average cost function must be set to 0. So we differentiate the average cost function and set it to 0. So dq of AC equals to dq of q square minus 6q plus 15, and we set it to 0. Right? When the average cost is minimum, the first order derivative must be equal to 0. So we have set it to 0. That is q square ddq of q square minus 6q plus 15 equals to 0. So we get 2q minus 6 plus 0
equals to 0. So as we differentiate a constant number, we get 0. We differentiate q square, we get 2q. We differentiate 6q, we get 6. And we differentiate 15, we get 0. So ddq of AC is 2q minus 6 plus 0. So this gives us 2q equals to 6 or q equals to 3. So when q is equal to 3, the average cost of the firm is minimum, because we have set the derivative of the average cost curve, the average cost function, to 0. Now what will we do now? We shall put the value of q in the equation of marginal cost and in the equation of differentiated average cost. Sorry, in the average cost function, right? So putting the value of q in MC, we get what we get by putting the value of q in marginal cost. This is the marginal cost equation. So we get MC equals to 3 into 3 square minus 12 into 3 plus 15, which is equal to 27 minus 36 plus 15. That is 27 plus 15 is 42 minus 36 equals to 6. So the marginal cost is 6. Now let's see what the value of AC becomes. Putting the value of Q in AC. Putting Q equals to 3 in AC equation, average cost equation. What is the average cost? Q square minus 6Q plus 15, and we are putting 3 in place of Q. AC equals to Q square, so we put 3 square minus 6 into Q, we put 3 plus 15. So we get 9 minus 18 plus 15. That is 15 plus 9, 24 minus 18 is to 6. So MC is equal to AC. Here MC is 6 and here we have calculated AC as 6 when Q equals to 3. So when the average cost is minimum, the marginal cost is hitting the average cost curve at the letter's minimum point. We have taken one numerical example, that is a set of cost data, cost of producing certain levels of output from 10 to 20. So we have taken total cost, marginal cost and average cost, and we have proved that the marginal cost curve intersects the average cost curve at the letter's minimum point. And here I have used calculus to show that the marginal cost is equal to the average cost when the average cost is minimum. What I have done here, I have taken a cost function C equals to Q to the power 3 minus 6Q square plus 15Q. From here we have taken the marginal cost by differentiating the total cost with respect to Q, and we have got the marginal cost equation as 3Q square minus 12Q plus 15. Here we have calculated the average cost, that is total cost divided by total output, that is C by Q, which is equal to q cube minus e square 6q square plus 15q divided by q, that is q square minus 6q plus 15. This is the average cost. Now average cost would be minimum when the derivative of the average cost function is set to 0. So we have taken derivative of average cost curve, that is ddq of AC, which is ddq of q square minus 6q plus 15, the average cost curve, average cost function. So we have differentiated q square minus 6q plus 15 and we have got 2q minus 6 plus 0, which is equal to 0. Why? If average cost has to be minimum, then the derivative of the average cost function must be set to 0. So q equals to 3. Now I have put the value of q in marginal cost equation as well as in the average cost equation. Marginal cost is here 3q square minus 12q plus 15. So 3 into 3 square minus 12 into 3 plus 15. So we get 6. This is the marginal cost. And here we have put the value of q in the average cost equation, that is q square minus 6q plus 15. And we have got 6 as the average cost. So it is proved that when average cost is minimum, marginal cost becomes equal to average cost and the marginal cost curve intersects the average cost curve at the latest minimum point. Correct? Now I shall explain once again with the help of two other diagrams. And for doing that, I have to erase this part. Okay? Yeah. I am erasing this part. I have no other way because I don't have much space. I am drawing two diagrams. Yeah. On x-axis we measure Q quantity and on y-axis we measure cost C. Right? Here I have drawn the figures in such a way that in neither figure the marginal cost is intersecting the average cost curve at the latest minimum point. In this diagram, I have made the marginal cost intersecting the average cost curve at this point. And in this diagram, I have made the marginal cost intersecting the average cost curve at this point. Let the minimum point of this average cost curve be M and this is N. In this diagram, the minimum point of AC is M and in this diagram, the minimum point of AC is N. In this diagram, MC and AC are intersecting, say, at point N, and in this diagram, MC and AC are intersecting at point, say, R. Okay. In neither of the diagrams, the marginal cost curve has intersected the average cost curve at the latest minimum point, but it has intersected at some other points. Now here you see, when average cost falls, when AC falls, MC lies below AC. We have learnt right now, we have proved with numerical example and through calculus. AC falls, MC lies below AC curve. Now you see, it is okay. AC is falling MC is below AC. No problem here. Now you see this part. From N to M. Watch very carefully. AC is falling, but MC is above AC. So this cannot happen because we have learned that when AC falls, MC must lie below the AC curve. But here you can see that in this part, in this portion of average cost curve, average cost is falling, but marginal cost is lying above the average cost curve. So the marginal cost curve cannot intersect the average cost curve at point N. Okay, now come to this diagram. Here you see when AC is rising, when AC rises, MC lies above AC. When AC is rising, the marginal cost curve lies above the average cost curve. And why these things happen? These things happen because the rate of change of MC is more than rate of change of AC, whether it increases or it decreases. Now here you can see as AC is rising beyond point R, MC is above AC. No problem about it. But what about this part? From point N to point R. Here you see AC is rising, still MC is below AC. This cannot happen. Okay? That means MC will intersect AC only at the letter's minimum point and at no other points on the average cost curve. Correct? Yeah. So this is all about the relationship between short run average cost curve and short run marginal cost curve. In other way to say, why the short run marginal cost curve intersects the short run average cost curve at the latest minimum point. I believe this is well understood by you. Still, should you have any doubt in your mind, if you have any query, if you think any particular point needs more explanation, clarification, etc., if you want to know something else, if you want greater insights, please feel comfortable to let me know through the comment section. I shall be more than glad to respond to all your relevant queries. And if you think this video is beneficial for you, please do share the video with your friends, brothers and sisters and colleagues so that they can also derive benefit by watching this video. And please don't forget to like and share the video. And finally, thank you very much for watching this video. Stay well and goodbye.